6.2 video multiplying and dividing radical expressions. So we're going to talk about multiplying, dividing, just numerical. So basically saying no variables or just dealing with numbers so you can learn the concept. First thing, when we multiply two radicals together, it's basically they both have to be under the same root and they have to have the same index. So like here they have an index n and an index n. Whenever you have the same index, it's just multiplying the two numbers underneath the radical. So in this first problem, I can't do anything to this. So since I cannot simplify, my answer would just look like my original, just like this. And the reason why is because the index is not the same. Now if I look at my second problem, first you check your index, they're both index 3. So since they're both index 3, I can rewrite this as -4 times 2, and I have to make sure to write my index 3. This is going to become a -8, the index 3. Now once I multiply, I can see if I can simplify this. So if I look at my two numbers, this would be 2 times 4. Let's say this one's negative. And this could be -2 times 2. Well, because of this negative sign here, remember, because it's an odd index, that means my answer is going to be negative. So it really doesn't matter where I put the negative sign. And now I'm looking for groups of 3 because my index is 3. So I'm going to circle 1 and I'm going to cross out 2. So my final answer here would be a -2. And that would be it. Right now you should pause the video and attempt both A and B by yourself. The first problem you cannot do because the indexes are not the same. Second problem, since they both have an index 5, then I can multiply them. A -5 times a -2 is going to give me a +10. So I do write my +10 there. And I know I can't simplify this any further because I do not have any groups or 5 groups of the same number when I'm dealing with 10. So those would be my two final answers. We're just going to do a little review of simplifying a radical again, just to make sure that you can do this when you have a higher index than just 2. So first I'm going to do look at my factor tree, or look at my index, and it has an index of 3, so that means I'm looking for groups of 3. Then I'm going to make my factor tree. So this is my factor tree. Now, I could have gone even further with the 4s that I have. However, I'm looking for groups of 3. It doesn't matter at what point you have. As long as you have a group of 3, then you're going to get the correct answer. So I'm going to circle 1 4 and then cross 2 other 4s out. So my final answer here, the 4 can be taken out because it's circled. And then I still have a cubic root of 2. Now, if you would have done the factor tree like so, you're still going to get the same answer because I'm still looking for groups of 3. So I'm going to circle 1 2 and cross 2 2's out. Circle 1, cross 2 2's out. So now when I look at this, I have a 2 here and a 2 here. That would just be 2 times 2. Both of those get taken out of the root, and then I still have a square root to 2. Either way, I still get my final answer to be 4 the cubic root of 2. So multiplying in simplest form, first thing you want to do is, are the indexes the same? Yes. When there's no index, that's just an index of 2. And then I'm going to multiply them together, so I have 720. And now do your factor tree, and I'm looking for groups of 2. And again, on my factor tree, I'm going to stop right there because I see I have 2 groups. So I'm going to circle 1 2 and cross 1 out because I'm looking for pairs because that's my index. I'm going to circle 1 6 and cross it out. Again, you could have gone farther, so you're doing prime factorization, but either way, you're going to get the same answer. So now when I look at this, I have a 2 and a 6 on the outside. That can be written out because both of those are circled. The only number left on the inside that doesn't have circled, cross out, or branches is this 5. So then it'd be square root of 5. So my final answer would go 12 square root of 5. Another way that you could do this is to write out the factor tree first. So if I look at this factor tree, I can go 9 and 5. This factor tree can be 7 and 5. And then I could have a 3 and 3. Now they have the same index. The index is 2. When I multiply them together, I'm looking at this as if it's one big factor tree. So now I'm looking for my groups of 2. So here's a 3, cross 1 out. Here's a 5, cross 1 out. So I'd have 3 times 5 square root of 7, because that's the only number left inside with the nothing, so that'd be 15 square root 7. Either way you do it, as long as you have your math correct, you'll get the same answer. Now when we're dividing radicals, one thing that you do, and again, you have to make sure that they have the same index, is whenever I have a radical A over a radical B, that can always be written as the radical over the fraction A, B. Why would we want to do that? So if I had 32 over radical 2, I can rewrite that so it looks like 32 over 2. Now I can simplify this fraction, because now it's just written as a fraction, and 32 divided by 2 is the square root of 16. And now that I just have the square root of 16, that's 4. So it's just an easier way to simplify fractions. Now this concept goes both ways. So if I had one large square root over 16 over 81, I could rewrite that to square root of 16 over the square root of 81. Why would I want to do that? Well, both 16 has a perfect square of 4 and 81 has a perfect square of 9. So it can go both ways, this concept. Right now you should pause the video and see if you can get the same answers as I do for both these problems. Be careful, this is an index 3. The first one comes out to be a square root 9, which is 3. The second one comes out to be the cubic root of 54, so I did my factor tree, and I found that I have 3, 3. So I circled 1 and crossed 2 out. Then a 3 was taken out, and then I'm left with a 2 inside with the index 3. You always have to make sure to rewrite that index correctly. That'd be your final answer. And just in case if you've forgotten to rationalize the denominator, we're going to be going over this tomorrow more in class. For you cannot have a radical or a root on the bottom of a fraction. It's just not proper, so we don't do it. So we always want to multiply the fraction by a number of 1. And to figure out what that number should be, you always look at what's the radical on bottom, because that's what I'm trying to get rid of. So you multiply that same number on bottom. In order to be multiplied by 1, that same number has to be on top. So that's just rationalizing the denominator. That is it for today. Have a wonderful evening. I'll see you tomorrow, or whenever I see you.